It's been a lot of long sessions on this board. It's definitely getting harder. Taking more time with the explanations. Right. So, in the case of where the symbol that you initially push, if it's the same as the symbol you finally pop, if those two are the same, then your APQ you can rewrite as little a here. Okay. You can rewrite as little a, that's the symbol that you read, the first symbol of your X, first symbol of your input. ARS, that's another variable similar to this, and B is the last symbol in your input, string X. Alright, and these R and S, what are they? Well, the next state after P is R, and the state before Q is S. Right? So R is the next state of P, and Q is the next state of S, so to speak. Right? Now you may ask, why are you doing this? Well, it's not at all clear at the moment, and that's perfectly normal. But this is what you're asked to do, and doing this will eventually enable us to prove that it's possible to get a grammar to behave like a PDA, right? Because that's what we're trying to do. All right, now let's do the other case. What happens when the symbol that you push is different from the final one that you popped, and that implies that the stack has emptied previously. It's not the first time that the stack has emptied. So in that case, it has emptied before, and when that happens, let's say. Okay, when the state does empty previously, okay, let's say the state of the machine was in state little r. Okay, so in the case when the initial push symbol is different from the final popped symbol, that implies that the stack has emptied more than once. Okay, so the first time it empties, let's say the state of the machine then was state R. Okay. So then you rewrite your APQ in this way. You rewrite it as APR, ARQ. Okay. And remember, little r is the state when the stack empties prior to the end, before the string X has been read. Right, so you have those two possibilities, and each time you change this variable APQ to this when the two are different, and you change this to this when they're the same. And doing this construction will enable you later to prove what you're trying to prove. In other words, that a grammar, context-free grammar, CFG, can behave like a PDA. In other words, they're equivalent. That's what we're trying to prove. All right. Now, some some more tools. Have a look at these two diagrams. Now, remember, this is the case when your initial pushed symbol is different from your final popped symbol. Okay, that's this diagram here. So that means, like I said before, that the stack has emptied previously. So in total, once you've read through your string x, the stack has emptied twice at least, okay, but more than one time. So if this vertical axis represents the stack height or stack depth, if you like, how many things in the stack. Well, it starts off at 0. That's in state when the PDA is in state P, right? It empties at state R and fills up again and empties again at state Q. Okay, so now there may be more than one intermediate emptying, right? There might be more, but well, okay. So now your input string is well, that's represented along here, along this axis. So you have like symbol 1, symbol 2, 3, 4, 5, 6, 7, okay, so this symbol string's represented along the horizontal axis, and stack height by the vertical axis. Alright, now in the case where the initial pushed symbol is different from the final popped symbol, you'll get the stack clearing more than once, and your APQ will get instead of writing this, you'll write it this way, where your R is the state of the machine, the PDA, when the stack cleared for the first time. Okay? Alright, and now similarly here, in this case, that's when your initial pushed symbol is equal to the final popped symbol. Right? In that case, there is no intermediate clearing of the stack. Right? There's no emptying of the stack. The first time it empties is here. Just a minute. Oh, maybe I've left out P and Q here. Okay, let me just check. Yes, I have. Damn. I should have a little P here and a Q here. And so these are state. They're identifiers of the state, and I should have an R here. That's like the next state, and an S